The global enterprise software market is undergoing a structural realignment. The traditional centralized software model is fracturing, and that break is threatening to destroy billions of dollars in established valuation. At the center of this market panic is the SaaS apocalypse. This represents the permanent decoupling of a company's operational output from its human user licenses. For 15 years, SaaS economics followed a predictable scaling model. An enterprise expands its headcount, the vendor sells more individual user seats, and Wall Street rewards that recurring revenue with high valuation multiples. In early 2026, advanced agentic workflows broke that math. Systems like Anthropic's Claude Cowork demonstrated the capacity to execute multi-step business tasks, from financial analysis to project management, with minimal human oversight. The financial fallout was severe. Within 48 hours of these capabilities hitting the market, approximately $285 billion to $300 billion in public software capitalization was wiped out, as investors realized that per-seat revenue was no longer durable. The underlying economic reality is now clear. Revenue models tied to human headcount growth are structurally incompatible with the automation of the modern enterprise. This chart shows the diverging market trajectories defining this transition. The upward line represents projected global AI agent spending, which is spiking toward $376 billion by 2027. The plunging line represents the percentage of SaaS vendors utilizing pure seat pricing, which is collapsing below 10%. The math here is punishing for incumbents. Because a single autonomous agent can replace the operational footprint of multiple human employees, enterprise clients can slash their active software seat counts while increasing their output. For traditional vendors, efficiency results in massive revenue contraction. This is compounded by vibe coding, a trend where low-code AI tools allow enterprises to quickly assemble custom, lightweight internal applications on the fly. Organizations are increasingly choosing to build tailored micro-applications rather than purchasing broad, expensive software suites. This brings us to SAP SE. As a legacy giant in the system of record market, SAP is executing a counteroffensive to survive this transition. At its Sapphire 2026 conference, SAP outlined its autonomous enterprise vision. It is a transition from a UI-driven application for human workers into a governed orchestration layer where specialized AI agents collaborate to execute processes. SAP's survival strategy hinges on re-engineering its entire architecture, moving from selling software access to monetizing automated business outcomes. Despite the massive influx of capital into AI, the enterprise sector is currently stuck in an execution gap. According to IDC, while 81% of organizations have an active AI strategy, only 11% have managed to deploy AI agents at scale. Agents fail in the enterprise because they lack real-time semantic context. When fed data through fragmented storage chains and fragile pipelines, agents cannot access the strict business logic necessary to make accurate, high-stakes decisions. To solve this, SAP built a new architectural stack. The bottom layer shows siloed databases, S/4HANA, and external data. Analyzing them together required complex, fragile ETL pipelines. SAP eliminated this bottleneck by acquiring Dremio, dropping a unified data lakehouse layer directly on top of the silos. By natively supporting open table formats, Dremio decouples storage from compute. SAP can now run high-performance, federated SQL queries across both environments simultaneously, without ever physically moving the underlying data. By destroying the ETL pipeline, SAP establishes a real-time data federation layer. This clean foundation feeds the SAP Knowledge Graph, ensuring its AI agents operate with consistent semantic context. There is a persistent professional misconception that general-purpose large language models are capable of running core business operations. They are not. General-purpose LLMs excel at language, but their probabilistic nature fails at mathematical precision and tabular reasoning. You cannot trust them to reconcile a corporate ledger. To address this computational gap, SAP committed over €1 billion to acquire and scale an independent European AI research lab called Prior Labs. Prior Labs specializes in tabular foundation models. Unlike LLMs, they natively process structured business records, achieving the predictive accuracy of a 4-hour machine learning pipeline instantly, without custom training. This allows an enterprise to execute highly complex business math on the fly, instantly forecasting vendor payment delays, calculating supplier risks, or predicting customer churn from records. In a system of record, generic language models are merely translation tools. Specialized mathematical models trained on tabular data provide the precise, predictive layer that actually drives automated decisions. But data federation and accurate predictive models are still limited if the AI agent is blind to the human user's broader software environment. To solve the visibility problem, SAP executed a $1.5 billion acquisition of WalkMe. This creates the interface layer for what SAP calls its Joule Everywhere initiative. WalkMe's technology allows SAP's Joule Copilot to operate across both SAP environments and third-party applications. Joule can extract external context directly from browser tabs and feed it right back into an internal SAP workflow. To manage the execution of these tasks, SAP acquired N8N, an AI-powered orchestration engine. It allows organizations to assemble and automate multi-step workflows across disparate enterprise systems. We can see this architecture in the physical world through SAP's collaboration with the European energy utility RWE, focusing on autonomous asset management. When an offshore wind turbine reports a fault, SAP's agents pull from the unified data layer to analyze thousands of past incidents. The agents autonomously generate structured work orders, complete with exact tooling and repair instructions, minimizing unplanned downtime. By vertically integrating the interface, model, and data federation layers, SAP has transformed its ERP into a cycle-complete autonomous workflow engine. To determine if this strategy will hold up long-term, we must compare SAP's governed architecture against the primary CRM incumbent, Salesforce. Salesforce has adopted an open MCP-first posture. By embracing the Model Context Protocol, Salesforce designs its customer data to be highly readable and actionable for external third-party AI agents. SAP takes the opposite approach. It prioritizes process safety and transaction integrity, restricting external agents from writing directly to its core database. This matrix breaks down both systems across 3 layers: access, meaning, and authority. Diverging sharply in the access layer, Salesforce leaves the door open. Conversely, SAP forces all agent interactions through its business technology platform checkpoint, ensuring strict compliance with internal guardrails. At the authority layer, SAP enforces granular permission models. An agent might be allowed to draft a purchase order, but human-in-the-loop validation is hard-coded into the workflow, preventing an external agent from corrupting the financial ledger. Open APIs are effective for driving rapid AI adoption in front-office sales environments. However, mission-critical supply chains and financial ledgers demand the strict walled garden governance that SAP provides. A major friction point remains for SAP, an installed base of over 20,000 legacy customers still running highly customized on-premises ECC or S/4HANA environments. Because SAP initially restricted Joule agents to cloud customers, these legacy clients began exploring third-party AI wrappers that could connect to their local servers. This threatened to bypass SAP's cloud migration path entirely. To neutralize this threat, SAP executed a tactical concession at Sapphire 2026. The company announced it would bring its Joule agents to hybrid landscapes, allowing local connection to legacy on-premises environments. But the access has a strict commercial catch. To unlock the local AI agents, legacy customers must commit to cloud, enroll in premium success plans, and document an active migration tramline. SAP has transformed its AI capabilities into a tactical lever, designed to force stubborn on-premises holdouts into committing to cloud migration contracts. The probability of SAP surviving the transition to a post-seat pricing economy depends on its specific structural defenses. Its primary defense is deep operational integration. It requires massive capital and immense operational risk to replace an ERP system hardwired into manufacturing lines and global trade compliance networks. This creates data gravity. Without SAP's structured context and strict permission frameworks, external AI tools cannot execute tasks safely, inextricably pulling them into SAP's ecosystem. The final requirement for survival is the transition toward consumption pricing. By charging for the volume of autonomous outcomes successfully delivered, SAP ensures its revenue can expand even as user counts contract. In an economy where an AI can instantly generate a software interface, the user interface is no longer a defensible moat. True market power resides exclusively in proprietary, deeply governed transactional data, making SAP's structural defenses arguably the strongest in the enterprise sector.